Hey, welcome to our second video in our complex numbers series of our maths module. So for this video we're going to be looking at addition, multiplication and division. So we're going to give ourselves a few different complex numbers to work with. We'll just fabricate three different complex numbers. We'll call these Z1, Z2 and Z3. So Z1 will give ourselves 3 plus I4. Z2 we will give ourselves 2 minus I3, and for Z3 we're going to give ourselves 3 plus I. We're all just going to use low numbers for this example as it makes it a lot simpler to learn from. So first we're going to start with addition because that's the easiest. We'll take the sum of Z1 and Z2. So this is very, very easy to sum two complex numbers. This is simply, an easy way to write this out is to look at the two real components and then the two imaginary components separately. So we do 3 plus the 2 plus the I4 minus the I3. Then we just sum these separately, so we get 5, then we take 3 off 4, that's 1I, so just I. And that's it. That is how simple it is to sum numbers. You just add the individual components together of the real and add the individual ones of the imaginary. So if we were then going to sum, say, Z1 and Z3, we can see we have 3 and 3, so that's 6, and we can see we have 4I plus 1I, so that's I5. And that's how simple addition is. So we move swiftly on to multiplication, because multiplication is a slight bit more difficult, but it's not too hard. So we're going to multiply first. We will do Z1 by Z3. So we do Z1, Z3, and this then we can say is equal to, we'll do it in brackets, so we do 3 plus I4, and in the other set of brackets we do 3 plus I. And now we just multiply out our brackets. So 3 by 3 is 9, and then we do each of our real terms against our imaginary terms, so we do plus I, and open ourselves up a bracket. So we have 3 by 4 is 12. And we have 3 by 1i, which is 3. And then finally we do both of our imaginary terms together, which gives us I squared by 4 and 1, which is just 4. We can take this down again, and we have 9 plus 12 plus 3 is 15, so I15. Now we know from our last video I squared is minus 1, so that means we have minus 1, and then minus 1 is times by 4, there. So now we can simply just take the 4 off the 9, which gives us 5 plus I15. So that's nice and easy. And now notice I'm always leaving it this way around, and this is the form of Z equals A plus IB. In many exams you'll be asked to give it in that form, so even if we had an answer with no I term, we'd still put I0. If we had no real term, we put 0 plus I and then the 15. Just to remind you of that. We'll do one more multiplication. We will just do Z2 by Z3. And we'll do this one faster than the last with less steps. So do Z2, Z3, and we'll write down the brackets again. So 2 minus I3, 3 plus I. So now we can see we have 6 from that. Now if we do the real by the imaginary, we have plus I, we have 2. Now we have minus 9, and that gives us, we have an I there and an I there, so that's minus 1, but it's minus 1 by minus 3. So you have minus 1 minus 3, which we can just give ourselves to be plus 3. So you have 6 and 3 together is 9, and 2 minus 9 is minus 7. So we have minus I7. So the multiplication isn't too difficult. But now we are going to move on to the division. Now the division's a little bit harder. For the division, we have to look at two separate things from our last video. First, we need to look at our complex conjugate, where we remember that the complex conjugate has the reverse sign of the imaginary part of the imaginary number we're looking at. So we'll take two more imaginary numbers for this one. We'll take z1 is equal to 3 plus I4, and we'll take z2 to be equal to 2 plus I5. And also we need to look at the magnitude, because what we can find is if we have any complex number, so we'll take z1, and we multiply z1 by its complex conjugate, what actually we find is we have the magnitude of z1 squared, which in this case would be equal to 3 squared plus 4 squared, which is 25. And we're ignoring the square root because we're squaring the square root effectively. So now if we're going to do a division and we decide to do z2 over z1, we then multiply the top and bottom by z1 bar for complex conjugate. So we have z2 z1 bar all over z1 z1 bar, which then is equal to z2 z1 bar over the magnitude squared. Now you don't have to write out all of these steps, of course, but for the first time I'm just illustrating how this works. And then if we ignore the bottom term for a start and we just do a multiplication nice and quickly of z2 by z1 bar, and then we'll address the denominator afterwards. So we come to do, like before the multiplication, z2 is 2 plus I5, and z1 bar will be 3 minus I4. This then gives us 6 plus our I terms, which is 3 by 5, which is 15, and it's 2 by minus 4, which is minus 8. And then we're going to have our final term. So we have I by I is minus 1, and we have a minus from here, so we can ignore all of that, and we just have plus 20. So now we can sum all this together, and we find we have 26, 15 minus 8 is 7, so we have plus I7. And then we can put all this together now to say we have 26 over our denominator, which is 25, plus I7 over 25. Once again, notice I've left it in the forms of z, well, z2 over z1 equals a plus ib.